In this video, I will show you how to take a general form equation of a conic section, like a circle, parabola, ellipse, or hyperbola, and rewrite it in standard form. To accomplish this, we will be completing the square. Now, at a glance, I know this is a parabola. I know this because only one variable is squared. And because the y is squared, I know that the model that we are shooting for is y minus k squared is equal to 4p times x minus h not squared. So, this is our goal. To do this, we need to group together the y terms on the left side of the equation. So I have a y term here and I have a y term here. Everything else is going to have to go to the other side of the equation. The 12x is going to have to go and the 2 is going to have to go. So when I rewrite this equation, I will have 2y squared minus 20y, and then I'm going to go ahead and subtract 12x from both sides, so this will be negative 12x. I'm subtracting 2 from both sides, so I'll have minus 2. Before I complete the square, there's this thing where we do half the middle squared. You can't do that now. You have to take this coefficient outside of the parentheses first. That's a common mistake I've been seeing lately. So if I take the 2 out, I'm going to have y squared minus 10y. I need to leave space to complete the square. So now I do half the middle squared after pulling the 2 out. Half of this is negative 5. Square it, that's positive 25. Well, actually, it's not a positive 25. Hold on, let me copy this down first. So I've got negative 12x minus 2. It looks like a positive 25, but this is really 2 times 25. So this is really 50. So that's why I need to add 50 on the right-hand side to balance that out. So if I factor this, I'm going to have 2, and then I will have y minus 5 times y minus 5 equals negative 12x plus 48. So this is going to be 2 times y minus 5 squared, because there's 2 of them. Time to pull out this negative 12 outside of parentheses. Okay, so that's going to leave x minus 4. Okay, I'm just dividing both of these by negative 12 as I pull it out. And finally, if you look at the model of the parabola, notice there's no number in the front. So I can't have a 2 sitting out there. I need to get rid of that by dividing both sides of the equation by 2. So that's going to give me y minus 5 squared is equal to negative 6 times x minus 4, not squared. So this is the standard form equation of the parabola. Notice how it matches the model. For number 18, I can tell that this is another parabola. Again, because only one variable is squared. This time it's the x that is squared. So I know it's going to be this version. X minus h squared is equal to 4p times y minus k not squared. The x is squared, so the x part will be squared. So this is going to be very similar to the problem I just did. Since I want the x squared on the left, I'm going to leave the x stuff over here on the left, and I'm going to move the y stuff to the right, and the constant. One thing that's kind of bothering me, I'm not liking the fact that there's this negative sign here. So I think I'm just going to divide everything by negative 1 just right at the beginning, just to get that out of the way. So then I'm going to have positive x squared minus 12x plus 12y plus 37 is equal to 0. I feel better about that. Now I'm going to leave the x squared and the minus 12x on the left side of the equation, but I'm subtracting the 12y and the 37 to move it to the other side. So that will be negative 12y minus 37 on the other side. Time to complete the square. Make sure there's no number sitting here that you have to pull out. Anyway, half the middle squared. Half of this is negative 6. Square it, and you've got 36. So I need to add 36 to both sides of the equation. So if I factor this, it's going to give me x minus 6 twice is equal to negative 12y minus 1. Okay, this is going to be a little tricky because I'm going to have to pull out that negative 12 in a second, but I'm going to make it happen. So anyway, I've got x minus 6 squared equals. So the 4p has to be outside of parentheses. So I'm going to have to take this 12 and pull it outside of the parentheses. When you factor a number outside of parentheses, what you are really doing is you are dividing. So we will have y plus 1/12. That's a very strange result, but that's what it is. I don't know what to tell you. It's ugly. But this is the standard form equation of the parabola. Now number 19 is an ellipse. I can tell that it is an ellipse because the x squared and y squared terms are both the same sign. They're both positive, but they're not the same number. If they were the same, like a 4x squared and a 4y squared, it would be a circle. So it's an ellipse. So the model is going to be one of these type deals, x minus h squared over, let's say, a squared plus y minus k squared over b squared is equal to 1. This is the general form of it. I don't know if the a squared will be first or second, but the way we accomplish this is by grouping together the x terms, okay, and the y terms. I'm going to move this 4 to the other side of the equation. So I will have 4x squared minus 8x plus 9y squared minus 36y equals negative 4, because I moved that over. You know how we do half the middle squared and we add it to the other side? It's not time for that yet. I've seen several students making the mistake of doing half the middle squared right now. Because we have this 4 in the front, you have to pull that outside of the parentheses first. So I'm going to have x squared minus 2x. I'm going to leave space to complete the square. I have to pull this 9 outside of the parentheses before I do half the middle squared. So that's going to leave y squared minus 4y, leave space, is equal to negative 4. Now that you have pulled out the leading coefficient, now you complete the square. Half of this is negative 1, square it, and that's a positive 1. But actually it's 4 times 1, so that's a 4. So that's why I'm going to add 4 on the right hand side. Meanwhile, over here, half the middle is negative 2. Square it, and that's positive 4. But really, it's 9 times 4. That's 36. That's why I'm adding 36 to the other side. If I factor this, this is going to be 4 times x minus 1 squared. This is minus, so this is minus. And then I will have 9 times y minus 2 squared is equal to 36. These cancel out. For an ellipse, you need a 1 right here. So that's why I need to divide everything by 36 right now to get the 1. So I'm going to divide by 36 all three terms. Now I'm just going to reduce these fractions. 4 goes into 36 9 times. So I will have x minus 1 squared over 9, and then plus y minus 2 squared over 4 is equal to 1. So this is the solution. This is the standard form equation of the ellipse for number 19. Number 20 is another ellipse. Again, it's because the x squared and y squared are both positive. They're both the same sign, but the coefficients are not the same number. That would be a circle, but since the numbers are different, 20 and 1, that makes it an ellipse. So again, it's going to be this type of deal. X minus h squared over a squared plus y minus k squared over b squared is equal to 1. The b squared could be on the left and the a squared could be on the right. That doesn't matter right now. What matters is we need to group together the x terms and the y terms. And the 129 needs to go to the other side. So that's going to give me 20x squared minus 120x plus y squared minus 14y is equal to negative 129. Do not do half the middle squared yet. You need to take this leading coefficient outside of the parentheses. So I'm dividing by 20. Okay, so this is going to be 6x. Leave space to complete the square. This one doesn't have a coefficient, so I can just go ahead and write it down. Y squared minus 14y, leave space to complete the square, is equal to negative 129. Now I can do half the middle squared. Half of this is negative 3. Square it, you get 9. This is really 20 times 9, so this is really 180. Half the middle squared right here is negative 7. Well, half of this is negative 7. Square it, you get 49. There's nothing to multiply by, so I'm just going to add 49. If I factor this, I will have 20 times, and this will factor as x minus 3 squared. This one will factor as y minus 7 squared. Let me add these up. That's 100. Great. So as I said before, we need a 1 right here. That's why I need to divide everything by 100. So I need to reduce this fraction. So this will be x minus 3 squared over 5. And this will be y minus 7 squared over 100 is equal to 1. And that's it. This is the standard form equation of the ellipse for number 20. Well, number 21 is a hyperbola. I know this because I have a positive squared term and a negative squared term. If the signs are different, it's a hyperbola. So the idea will be that we will have x minus h squared over a squared minus y minus k squared over b squared is equal to 1. this is what the standard form model looks like. So once again, we will accomplish this by first grouping together the x terms and the y terms. I'm going to move the negative 36 to the other side. So I'm going to have x squared minus 4x and then minus 4y squared plus 24y is equal to 36. So x squared minus 4x, I'm going to leave space to complete the square. This negative 4 has to be brought outside of parentheses before I do half the middle squared. So I will have y squared. I'm dividing by negative 4, so I'm going to get negative 6y, leave space to complete the square, is equal to 36. Now I can complete the square. Half of this is negative 2. Square it, you have positive 4. There's nothing to multiply by, so I can just add the 4 to the other side. Half of this is negative 3. Square it, and you have positive 9. But this is really negative 4 times 9, which is negative 36. So that's what I add to the other side. When I factor this, this is going to factor as x minus 2 squared, and then minus 4 times y minus 3 squared is equal to 4, which is easy because the positive 36 and the negative 36 cancel each other out. According to the model, we need a 1 right here for hyperbolas, so I need to go back and divide everything by 4. So that's going to give me x minus 2 squared over 4 minus y minus 3 squared over 1 is equal to 1. So this is the standard form equation of the hyperbola. Number 22 is another hyperbola. And again, I know this because the signs of the x squared and y squared terms are different. One's positive and one's negative. Whenever that happens, it is a hyperbola. The model for a hyperbola looks like this: x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So this is what we're shooting for. The first step is to group together the x terms and the y terms and move this 260 to the other side by subtracting it. So I will have 9x squared minus 180x and then negative 16y squared minus 64y equals negative 260. Do not do half the middle squared right now. We need to take this leading coefficient outside of parentheses first. Dividing by 9 gives me negative 20x. Leave space to complete the square. This has to be factored out, so I'll have the 16 out there, and then that's going to be y squared plus 4y, leave space to complete the square, is equal to the negative 260. Now it's time to complete the square. Half the middle squared. Half of this is negative 10. Negative 10 squared is 100. But this is really 9 times 100, so I'm going to have to add 900 to the other side. Half of this is 2. 2 squared is 4. But this is really negative 16 times 4, which is negative 64. So I'm going to have to put that on the other side of the equation. Now it's time to factor. So this trinomial will factor as x minus 10 squared. This trinomial will factor as y plus 2 squared. These add up to 576. We need a 1 right here, so that's why I'm going to divide everything by 576. It turns out that 9 goes into 576 64 times. So this is x minus 10 squared over 64 minus 16 goes into 576 36 times. So this will become y plus 2 squared over 36 is equal to 1. So this is the standard form equation of the hyperbola. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.